Okay, I was messing with this Midway power brick. It is a, see there, A9450020 quad zero at the end there. But you see these in a lot of the MCR games. And this one actually came out of a Spy Hunter. It was rusted up pretty bad, but I wanted to test the power supply, which I have a couple of them on the bench. And so to do that, I needed to figure out how the AC connector is pinned out. So I figured I'd give a quick little overview. Just a few things on okay, sorry about that. Quick overview of what we see on the top side. One, we have the isolation transformer here. That's going to provide isolated AC to your monitor. We have a capacitor here that is tied into this other power transformer, which actually takes direct AC power from the line and puts out some unregulated DC voltages. Is what I think it's doing. I'm having troubleshot this part. We also have several fuses here, two being for the 5 volt line, two being for the 12 volt line, and then this other one this one with the orange wire is also from the 12 volt line, but it's not coming from the power transformer, it's coming from the isolation transformer, and it's also 12 volt. And we'll figure out maybe if this, I'm not sure if this is AC or DC when it comes out of the ISO. So we also have two filter caps here, which is filtering the 12 and the 5 volt. One's for the 12 and one's for the 5 volt lines. So that's kind of important. And then these connectors over here actually go to the power supply, which is over here. So we got AC line in. And what that does is, you have you can barely see it, I guess. You have a hot and a neutral, and usually the hot is fused, and the neutral goes straight to a distribution block. And so this hot actually runs to this 4 amp main fuse here. So if you don't have any AC power, you got AC power coming in, but you're not getting it over here going into the cabinet, you gotta check this AC fuse block right here. Let me stop and then I'll show you the underneath real quick. Okay, so the lighting's kind of bad. Let's see if I can get it a little bit better. So here's the isolation transformer, and on the underside you have your plug for your cabinet distribution. And then you have a distribution block here for all the AC power. So, basically, what happens is when your power comes in, the hot is actually this blue line, runs over to this blue distribution block, and then that also feeds your service outlet, where you see the black right there and the white. And from there, basically, in the cabinet, it will switch it from this hot. Actually, where's the fuse at? It comes, and it gets. Oh yeah, okay. It comes in to this distribution block, goes through the fuse. So basically, your service outlet is not fused. So it comes in, goes through the fuse right here, through the line filter, and then from the line filter to the cabinet, and that's where you would start using a switch, and the interlocks would come into play. So power comes in on the hot side to this distribution block, feeds your hot to your service outlet, also feeds the hot to the fuse, from the fuse into the line filter to the connector, which you can't really see, but it's over there. So that's that part. And then from that connector, once the interlock switches or the on-off switch actually distributes power to this part of the connector, you'll feed, it basically feeds this transformer. One of the transformer lines is always being fed by the neutral, and then the hot, which line is being fed by the hot, is based off of the power selector jumper, which is down here. I know it's upside down, but I'm just giving you a brief overview. Once that power comes into the transformer, then it's isolated, comes out with these black-white wires here, go to your monitor, and this orange and gray and red go to your 12 volt, which has its own special fuse, I guess, for the audio portion of the it says audio on the amp, so we'll trace that out a little bit. But that goes over here, and then on this side you can see the filter capacitors on the underside right there. And basically, it comes, you know, out from the underside through the fuses back into the filter caps after it gets fused, and then back out to the power supply after it goes through the filter cap. So that's kind of a quick overview of the underside, what's going on there. I didn't really talk about this power transformer assembly, but it's definitely leveraging this other semicircle capacitor. And I thought it might be fused as well. The other fuse I was going to talk about is the other fuse down here is really just a separate fuse for the straight unisolated AC that goes to the fluorescent lamp or whatever else is going to be in there. So there's a dedicated fuse on the underside that gets the straight wall voltage unisolated. And yeah, I'll stop there. Okay, so I grabbed the schematics, and you know, none of them are very clear on what's going on, but this side of the schematic is definitely talking about connector 3, which is, you know, the connector that goes to the cabinet. The interlock switches determines whether it's set up for 105 volts, 115, does the jumper to the isolation transformer, etc. And you can kind of see it for the most part, but it's not real clear in the printouts or copies that are online. So what I ended up doing is just kind of tracing it out myself, and I kind of show you the connector here, if you can see that. Basically the connector starting from this side, actually let me pull these jumpers out. It's got like a instead of a complete circle, it's kind of like a D facing up or something, like a half circle. That's pin 1 down to the left, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I kind of took that connector and then just drew it out on a piece of paper, with the bottom left being 1. And this is pins 1 and 2 is basically where your AC voltage from the outlet, from the wall, is coming in. Now obviously it's going through a fuse underneath this power chassis here. Before it gets to this part, we talked about that. It goes through the fuse and the line filter, and then it hits these two pins right here, pin 1 and 2, the AC voltage. But it doesn't go to anywhere to the cabinet yet, because you have interlock switches and power, you know, the on-off switch before you can get it to the cabinet. You also have to tell the transformer, you know, what voltage it's going to get. So what happens is we got to, you know, basically create, if we're going to test these on the bench, we got to jumper them. And so if you looked at the power distribution blocks on the inside, pretty much, you know, pin 7 and 4 are your, you know, your blue-white or your direct connections to your hot line. So once you pull the interlock switch, it basically makes a connection between pin, sorry about the focus there, between pin 1 and pin 4. And then, you know, AC power will be seen on both pins 4 and 7, obviously. Pins 10 and 13 are run through that separate 2 amp fuse but are also just AC power, but it's actually going through this 2 amp 250 volt fuse for the fluorescent lights. So, and then on the neutral side you have pin 2, and it gets jumpered to, could be, it was actually different on my cabinet. I think the schematics say it gets jumpered to pin 14. Mine was actually going to pin 11, but it really doesn't matter. I mean, pins 8, 11, and 14 are all, basically the neutral side. Pin 5 is actually tied to a 6.3 AC voltage line on the transformer, so it's it's only creating a 6.3. So if you wanted to, I haven't seen any MCR, I only looked at the Spy Hunter, so this is not used on the Spy Hunter, but if you wanted to run 6.3 volts AC, you could tap into this 5 volt connector, 5 volt pin, as an example. So the first thing we need to do is we basically need a jumper. If we're testing on the bench, we have to act like we're an interlock switch. So we got to take, pin 1 and jumper it to pin 4. We got to take pin 2 and jumper it to pin 8, 11, or 14, one of those. It could have been either one. So let's do that real quick. And I just created tiny little jumpers. I'm not even creating it putting pins on them or anything like that, or sockets or something. So I'm just going to take pin 2, obviously the power's off, and put that into pin 8 like that. And then for the hot side, I'm going to take pin 1 and go to, let me do this off camera real quick. Okay, so I have it all jumpered. So it's basically bypassing the interlock and on-off switch. As soon as I power on, plug this in to the wall outlet, it's going to have power going to wherever it's going. So there's no on-off switch. Now the next thing I have to do is actually jumper to tell the isolation transformer what voltage that it should be expecting. If we're wiring it for 115 volts from the house, or am I on 105 volts from the house, or am I on 125 volts? So my house is actually, I'm getting 120 volts. It usually runs kind of high, like 130, but because I'm going through, what I'm seeing right now is about 120. So, and what normally is going to be wired for is this 115. So you're going to jumper pin 7, which is basically our hot line, over to pin 12, which then is the input. That and the neutral is the input into the isolation transformer. So we're going to go from pin 7 to pin 12. Now you also see down here pin 3 and 6. That is the voltage to the monitor. So this should be a step up transformer. So we're getting 120 into the isolation transformer, and we should see a little bit higher than that going to the monitor. But I'll run a couple experiments and bootstrap these basically to the different voltages, and we can see how that impacts the monitor voltage as well. Okay, so now I jumpered it. So pin 7 is going to pin 12, which is for the 115 volt. And let's turn on our multimeter. Have this EEV blog Bremen or whatever thing. This is pretty nice. Actually, I'm glad I picked it up. But we're going to put our red lead here, and it's all plugged in. You can hear a little bit of humming, so I got to be careful here, working with one hand. And we're going to monitor our AC voltage on the monitor. So this is isolated AC. Okay, and I'm getting 125 volts there. Sorry about that. It's kind of a glare. here. Actually, it has a little light there. So how do I get that light on? Press and hold. There we go. Maybe that helps a little bit. There we go. So 125 volts with that. Now, if we want to see what the straight regular voltage is, we'll put a red into there. Black. Now this is actually, because I'm on pin 10, this is actually running through that 2 amp fuse, but you can see I'm getting about 118, 119 there, which is basically, if I stick on my service outlet, which is right there, which is basically the same. And that's AC power going through the service outlet, which is directly coming from the wall. And that is directly here. So this is not isolated on this side. You just got, but on this, pins 3 and 6 is isolated. Pin 5 is my 6.3 volts. So all I have to do is tie that to any of the neutrals. Again, real quick, the neutrals, pin 14, 11, and 8 are your neutrals. And then after the interlock switch. And so you can see I'm getting 6.9 volts AC by going from pin 5 to pin 11. So that's where you would, if you wanted that 6 volts. So anyway, now we have power going to it, and you can hear the hum, and you know we'll measure over here in a second. But what I want to do is check what the output of the monitor voltage is when we change the strapping to 105 volts or 125 volts. Okay, so it's kind of hard to see, but I changed my strapping to jump from pin 7 to pin 9, which is the 125 volt, and I have my meter on the monitor voltage, and you can see now that I'm putting out 115 volts to the monitor instead of 125. So that's a decrease of 10 volts, which is what you would expect here, because the previous strapping was 115. So it's kind of decreasing it by 10 volts instead of based off of the voltage that's coming in. We got 120 coming in, and it's putting out about 115. So all right, let's try it the other way around, and we would expect to see, instead of 125 volts, we should see up to probably 130. Okay, so here you see I'm strapped with from pin 7 on the isolation transformer to pin 15, which is, that would be for closer to 105 voltage coming from the wall, and it is basically reading almost 140 volts on the monitor voltage. So according to the schematic, you want 115 volts going to your monitor. Can you see that? There you go. You can barely see it, and the monitor in there is a G07, so I don't know all this stuff off the top of my head, but I would think that it would probably be better for us to be strapped to 125 versus 115, even though I'm sure that the 115 isn't going to hurt anything either. Okay, we'll focus on the other side, on the power transformer here. Basically, it's getting fed AC voltage directly via the wall. It's not isolated or anything. And then it comes from here into the fuse. From the fuse goes to the filter capacitors. And I think the green is, yes, the green is 5 volts and the red is 12 volts coming from the power transformer. And this orange line is coming from the isolation transformer. So we have 2 5-volt lines and 2 12-volt lines. Goes to the filter capacitors, and then to this plug here, which goes, and this plug, these 4 wires go to this plug, which goes to the power board, and then this one goes to the power board as well, but it's the isolated 12 volt from the transformer. So let's flip it over real quick. Actually, my Spy Hunter that I picked up, actually, that came out of, was making wicked hum, and it's been noted that a lot of times on MCR Midway games, that hum comes from these filter capacitors. So most likely, if it's audio hum, it's going to be on the 12 volt line, I would think. And the 12 volt line is not, so here's the green coming in, which then connects to these, and then it's colored black, goes to this capacitor, which is a silver capacitor. And the red on this machine, on this block, it's silver anyway. And the red is the 5 volts, and that stays red and comes to this blue filter capacitor. And what I noticed is actually one of the cables here, if you can see it, is not even connected to the filter capacitor. And that goes, and it should go back to the connector. So I don't know, that might be the problem for the hum, is that maybe this filter capacitor was replaced and actually they didn't hook it up or something. So I'm gonna check that out, but I just wanted to give you a quick overview of that. And then I'll come back and we'll read the voltage on this side right here with these plugs. Okay, so now we're going to talk about this power transformer and test the outputs of this connector here, which is connector 1, 9-position connector 1. It's actually labeled the same way with the the little D's or the semicircles at the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. But I would say it's turned sideways right now. Now this diagram was hard as heck to read. I couldn't even really see what the heck was going on, but I finally was able to kind of trace out the lines and kind of make sense of it. So you have, instead of the 5 volts, it's actually 8 volts, I guess, unregulated, and you have the positive side, and which is black, and the negative side, which is black and white, and those cables are probably both on the top side and the bottom side if you look at it from underneath. And then you have it says 12 volts, but really it's 15 volts unregulated. So you have red and white is the common side, and the positive side is just a straight up red. So red and white and red go together, black and white and black go together. And what that looks like from a diagram standpoint is kind of like this. Really, the common side are all tied together. So we could put our black lead, test lead, into 2, 3, 5, 7, or 9. Those are all common, the common side, and then for your positive 8 volt unregulated, you want to go into pin 4, or in my case also pin 8. Oh, actually, yeah, that's in the diagram as well. So pin 4 and pin 8 to test with the red lead to test your 8 volt unregulated, and pin 6 for your 15 volt unregulated. And again, I found that one connection, that red-white connection, that was not tied to the filter capacitor, and that's actually on pin 5. So we'll notice that I don't get any readings when going to pin 5. So let's move our meter here. We're going to stick it into pin 5 first, our negative lead, and we're going to go to pin 4. This should be 10 volt unregulated, and get nothing. That's because that's not connected. So let's go to pin 2 with our black lead, and pin 4, which is our 8-volt unregulated DC power. So you can see, actually stand this up. Turn the light on real quick. There we go. So you can see here, I switched it to AC actually. There's DC power, 10-volt unregulated, and that's going on pin 4. So let's go to pin, what did I say? Pin 8. Pin 8 and pin 2. It doesn't matter what the common side is. And we got 10 volts unregulated. And now if we go to number 6, which is on the opposite side here, this is the 15 volt unregulated. I have 18 volts. So that's really what you should get. Just a quick review here, kind of looking at it this direction. Again, you can put the common in any of the common pins, so it could be pin 7, for example, and then I can go to pin 4, and that's going to do 10 volts. Pin 9, that's a common lead actually. Pin 8 is 10 volts. And then pin 6 is your 15 volts unregulated. I have no idea why the documentation says 12 volt COM and then 15 volt unregulated. It's confusing me for a little bit, but figured it all out. And you should be able to go to pin 5, which is also a common pin, but for whatever reason on mine they didn't hook it up to the capacitor, the filter cap. Go to pin 4. Of course I get nothing because it's not tied to anything. So, and lastly, coming from the ISO transformer, the orange line is this 12 volt. That actually goes to this 2-pin connector. Connector 4, 2 pins. It says 12 volts. And that is not DC power. So change it to AC and we get 13 volts AC. So that connector 4 is actually AC power, 12 volts AC power. And a little misleading because again the schematic shows COM and 12 volts. So I'm not an electrician, so I have no idea, but it didn't make sense to me. But it looks like it's unregulated 12 volt power. So that is, I think, pretty much everything I wanted to cover on the MCR Power Brick. Drinking Dogfish Head 60-minute IPA. Let's see here, 6% alcohol. Pretty good. Gets me through all this talking, so hopefully this was beneficial to you guys.